Okay, so this right here, it looks like, C is equal to Ka LB, no powers. That looks like a linear combination. So typically we say, if y is equal to like mx plus, like C or something like that, right?
Yeah.
This is y is a linear, it's a linear equation. Yeah. So it's a linear combination. So it looks like a C is a linear combination of A and B. Now here are three vectors, u, v, x, and it gives you their magnitudes, okay? And it says x lies between u and v. So let's just draw a rough picture. So let's say that's u, and let's say that's v, and let's say x is here. So x is the longest one, okay? So x is way here, okay? This is x. Okay, and angle of 20 with u, so this is 20 degrees, and 30 with v, so this is 30 degrees. Okay, now I would like to know this. Is it possible, what should the, right, k be, and what should L be in terms of v, right? So how should we adjust the size of u and v so that we get x? You can see that we would have to make this longer, right? Visually, we would have to make this one longer too, so that we get v.
Yeah.
Okay, so how do we figure out what those lengths should be? Okay, that's the question. Okay, there's two ways to do it. There's the component method and there's a sine law and cosine law method. Okay, we've been using a lot of the component method, right? Which one do you use more in school? Component method or sine law, cosine law method? So let's do it through the component method. So I know that the x's x component, okay, according to this diagram, if you imagine u is the horizontal, okay, x's x component is going to be 24 cosine of 20, right? X's y component is going to be 24 sine of 20. True? Yeah. Okay, let's figure out u's x component. U is all x component, right? So it's 10. And there is no y, okay? What about v's x component? It's going to be 15 cosine of 50.
V's x component? Yeah.
Right, v's x component, right? Right here. This length right here, right? Okay, this one doesn't have a y component, it's just 0. And let's say here, this is v's y component. It's going to be 15 sine of 50 degrees, right?
Yeah.
Okay. So we know this. We know that since we want to find this k and l, and we've broken down this vector x into two components. Okay, so we've broken it down into right, ux, sorry, not ux, xx, xx, and xy. So you can write the vector x in that form, right? Because we've broken into two parts. Okay, in fact, maybe it should be written like that. K, u is so this is ux and uy. I'm just writing this again into x and y components, okay? And this one here is L, V, Vx, and Vy. Okay, I'm just not gonna write that because it looks like it is a vector. It's just that they're horizontal or vertical right now. Okay. Now we can say this: x's x component is equal to Kux and LVX, right? So the x's are, this one would have to equal to this one times plus this one. The x's all have to equal to each other, and then also x, y, the y's would also have to equal to each other too. So K, U, Y, L, V, Y. Okay. Now, these are given. This one right here is 24 cosine of 20. Ux is 10. L, this is 15 cosine of 50, right? Here it's going to be 24 sine of 20. K, 0, that's gone. L, 15 sine of 50. So we have two unknowns, and now we have two equations. Equation 1, equation 2. Can we solve for L and K? From here we can find L right away. L is going to be 24 sine of 20 all over 15 sine of 50, right? That's L. You can plug that into right in there and find K. So let's call that 3. 3 sub into 1. 24 cosine of 20. 10K. Sub that in, and we're going to get 24. Actually, 15 is going to cancel out here. So we get L is 24 sine of 20. 15 sine of 50 times 15 cosine of 50, right? Do you see that cancels out? Yeah, so we have 10K. Let me write a little bit cleaner here. 24 sine of 20 cosine of 50 all over sine of 50. Alright, so I mean this is all meant to be done in the calculator, okay? So it's 24 cosine of 25 or 20 degrees minus 24 sine of 20 cosine of 50 all over sine of 50 times by 1 over 10 to isolate for K. Okay. So this is K and this is L. Okay, this is what I get when I punch it in the calculator. L is 0.71, K is 1.57, and that's what belongs here. Okay, that's a linear combination. Right? So X is 1.57U plus 0.71V. That's what it means.